This tutorial explains how to start performing a dynamic simulation in VOLTRA, with a focus on assigning dynamic boundary conditions, as well as generating graphical and text outputs. The corresponding exercise files can be downloaded from the link provided in the video description. In the previous tutorial, the outdoor temperature was defined as a constant value. In this session, we will replace that static value with a time-dependent parameter. Time-varying parameters are defined in the Functions window. You can open this window either by clicking the Functions icon in the top toolbar or by selecting Functions from the Edit menu. To create a new function, click inside the Functions window and select Insert After. Multiple functions can be created in the same way. Each function has a reference number. For temperature functions, the reference starts with the letter T, followed by a number between 01 and 99, for example T01 or T02. The letter indicates the parameter type, in this case temperature. Other parameters, such as surface heat transfer coefficients or power inputs, can also be linked to functions, as described in this table from the user manual. The status bar at the bottom left shows the available references that can be assigned. For the first function, enter the reference T01. Under Type, you will find several predefined function types. VOLTRA allows you to define functions in three ways: by using built-in templates, by importing climate files in EPW or TMY format, or by using a user-defined function file. The detailed explanation of these methods will be covered in the next tutorial. For this example, we will use the built-in sine function template. Once selected, the corresponding function graph is displayed. For parameters, define the sine curve. Parameter 1 is the mean value of the function. Parameter 2 is the amplitude. Parameter 3 is the period. Parameter 4 is the phase offset. For this example, we define a mean indoor temperature of 15 degrees Celsius, an amplitude of 5 degrees, a period of 360 minutes, and no phase shift. The resulting sine curve fluctuates between 10 and 20 degrees over a period of 6 hours. In the same way, create a second function T02 using the sine template and define the parameters as shown here. After defining the functions, link them to the interior and exterior boundary conditions. Open the Colors window. For color 174, assign the temperature reference T01. For color 170, assign T02. Before doing so, change the standard from EN10077 to EN6946, and then set color 170 back to HE. Once these references are assigned, the simulation will use the time-dependent temperatures defined by the functions. Next, define the time settings for the calculation in the Calculation Parameters window. Set the time step to 5 minutes. This means the model will compute results at 5-minute intervals. The startup duration represents the simulation time before results are recorded. This period allows the model to reach a dynamic equilibrium and depends on the thermal inertia of the construction. For a wall of this type, a startup duration of 1 day is typically sufficient. Enter 1 day as the startup duration. Then set the actual calculation duration to 12 hours. Click on OK to close this window. Under the Calculate menu, open Save Frequency. By default, this option is set to On, which means that solution files are saved automatically at each time step. This allows the results to be visualized later in the graphic output window. If this option is set to No, the solution files will not be stored, and graphical visualization will not be available. Only text output will be generated. For detailed models, saving every time step can create large data files. However, for this example, keep the default setting enabled. You can also adjust how often results are saved. For instance, if you choose to save every 3 time steps, the results will be stored every 15 minutes when using a 5-minute time step. To start the simulation, click the Calculate System icon in the top toolbar. Once the calculation is complete, open Graphic Output to visualize the results. Select Fill Temperatures to display the temperature distribution across the construction. The current simulation time is shown at the top right above the legend. You can move forward or backward one time step at a time using next time and previous time. The Go to option allows you to jump directly to a specific time step. You can also return to the first recorded time step at any moment. If you want to create an animation of the temperature evolution, go to the File menu and select Save Animation Images. Choose a location to store the image files. The software will automatically generate and save images for each time step, which can later be combined into a video using external video editing software. Additional visualization options are available, similar to TRISCO, including viewing boundary conditions, materials, isotherms, and analysis grid lines. Besides graphical output, VOLTRA can generate alphanumeric output in text and CSV format. The content of this report is defined in the Report Definition window, and written according to the selected report frequency by going to Calc, select Report Frequency. As an example, we will create a report where the first column contains time, the second column shows the maximum temperature in the concrete wall, and the third and fourth columns contain the exterior and interior boundary temperatures. Open Report Definition from the Edit menu. Insert 4 parameters using Insert After. Under Object, you can choose from options such as time, date time, color, node BC, border BC, material BC, output node, output block, control, and sun. First select time. For the second parameter, choose color and enter color 136, which corresponds to the concrete. Under type, select theta max to obtain the maximum temperature within that color region. The width setting defines the maximum number of characters for formatting the output values. And decimals determines the number of digits after the decimal point. For the third and fourth parameters, define the exterior and interior boundary temperatures by selecting the corresponding colors 170 and 174. And choosing theta as the output type. Many other output parameters are available under type, and a complete overview can be found in the manual. Next, go to the Calculate menu and select Report Frequency. If you enter 1, a report line is written for every time step, which in this case is every 5 minutes. If you enter 2, results are written every 2 time steps, or every 10 minutes. After defining the frequency, run the calculation again. When the simulation is complete, open Text Output and select the Report Output tab. You will see the 4 columns defined earlier. The first column shows time, the second shows the maximum concrete temperature, the third shows the exterior boundary temperature, and the fourth shows the interior boundary temperature. VOLTRA automatically generates a CSV file containing the reported values based on the defined report settings. This file can be opened directly in Excel or any other spreadsheet software for further processing and visualization. Alternatively, you can copy the results manually from the text output window. Select all data using Ctrl+A, copy it with Ctrl+C, and paste it into an Excel spreadsheet. Once imported, you can create charts to analyze and visualize the dynamic thermal behavior of the model. Thank you for watching, see you in the next tutorial.